Okay, so today we'll understand about TLS secrets in Kubernetes. So we already discussed about secrets. So you have generic secrets, Docker registry secrets. Okay, but here we'll understand this TLS secrets. But before understanding, let's understand what is this ingress. Okay, so we all know that ingress, it is just again an object in Kubernetes. Okay, and this ingress defines what DNSs or the path based routes this ingress controller should use. Okay, so basically this ingress defines all the rules on how to access your application from the outside world. Okay, so these ingress rules will be read by your ingress controller, and then ingress controller will change its configuration depending upon the ingress objects. Okay, so whenever you update the ingress or create new ingress resources, automatically the controllers will read them and it will configure them. Okay, so there are many ingress controllers which we already know. Okay, like AWS ELB is again a type of ingress controller, traffic ingress controller, nginx. Okay, so you also have HA proxy. So there are a lot of ingress controllers available. Okay, so ideally how they work, if you take this as your Kubernetes cluster. Okay, if I take this as a Kubernetes cluster that has a lot of applications. Okay, I'm just taking this as app 1. So this has your app 2 and this has your app 3. Okay, and how do you access this application from outside? Okay, so you can expose them through a service like node port and access it on the node port, or else you can access through a load balancer. The third way is to have an ingress controller like traffic or nginx or HA proxy. Then this ingress controller can route the traffic from the external world. Okay, so the from the external world, the traffic reaches the ingress controller. Okay, and the ingress controller will route the traffic according to the host or the path based routing. Correct? Okay, so let's say you have a DNS like, let's say, app1.com. Okay, then I can configure the ingress in such a way that it forwards the traffic to the app1. Okay, so this is only possible through a set of rules called ingress, right? Ingress object. So this is an actually running pod. This ingress is nothing but an ingress rule. Okay, correct guys? Or else I can also use path based routing. Okay, so the question here is, so the user, you know when once he enters the URL, it can be a DNS name, IP address, it reaches the ingress controller. Then ingress controller will forward the traffic to the backend pods. That is fine, but what type of traffic? So whether the traffic is encrypted or not. Okay, so we will see that. So here the traffic is not encrypted, it's an unencrypted traffic. Okay, but what if I want to encrypt the traffic? Let's say this is a web server. Okay, and there is this browser which wants to connect to this particular application. Okay, so how do I encrypt the traffic? How do I make sure that I have secured HTTPS communication? Hmm? Imagine this is an app. How do I make sure I have HTTPS? Come on guys, you already know.
Using certificates, right?
Yeah, so you will have a certificate and a key for it, right?
Yes.
For the domain. But then you'll configure it in the web server, certificate and key. Then anyone who wants to talk to this particular web server, they will be provided with the certificate. Now the browser will try to trust this certificate. Okay, and then you'll have the secured communication. Now here app 1, app 2, app 3 are also applications. Okay, so I want the data to be encrypted between the user and your actual application. The same is for the other application. Okay, which means every app should have its own certificate or the key. Okay, provided here. Okay, so I can put it here, right? So which means these reside inside your actual pod. Clear? Clear guys? guys.
Yes, Ikram.
Yes.
Okay, which means if I am the browser or the user, if I try to connect to this application, I'll have HTTPS. Okay, but instead of managing certificates and keys for the individual applications directly at the application, okay, so we call it as offloading at app level or offloading at application. So this is called SSL offloading, which means your SSL terminates at the app from the user or the browser till your application. All data is encrypted. Your encryption is at the app level. We call it as offloading or SSL termination at the application directly. Instead of this, what I can do is I can take these certificates related to my each application from the pod level, and since ingress controller is the entry point, I can configure their TLS data, I mean certificates and keys for individual applications, directly at the ingress controller level. Okay, now in between the browser or the user till the ingress controller, the data is HTTPS. From ingress controller to your actual backend application, it is purely HTTP. It's unencrypted traffic. But this is fine because this is your your internal network, which means internally the data can be unencrypted. But from the outside, like from the public networks till the ingress controller, it is HTTP. So the data, the communication is secure. So terminating TLS at the ingress controller, it is, you can call it as TLS termination at the ingress controller level. Got it? So if you don't take the case of your Kubernetes cluster, suppose this is a browser and this is your web server which is serving your application. If you have TLS certificates like certificate and key for your application there, then you call this as SSL offloading directly at the web server. Okay, but ideally what we will do is every organization will have their own reverse proxy, okay, as like a front end. Okay, now they will have all these certificates at the reverse proxy, and from the client or the browser, first the communication reaches the reverse proxy. Since reverse proxy is terminating, so here you'll have the SSL certificates till here it is HTTPS. From reverse proxy, again this is all internal network, the traffic can be purely HTTP. Okay, this way it is called SSL offloading at the reverse proxy. Okay, so you're not burdening your actual application. Got it, guys?
Yeah.
Yes, Vikram.
Okay, so here you have to offload at the ingress controller, so that ingress controller will receive the encrypted traffic, but internally it will forward in the plain HTTP. Let's see how to do that. Okay, so for this we know that there are two types of ingress rules. Like one is path based, the other one is the domain based. Okay, so if you see here, I can just have a single URL, but according to the slash endpoint, like slash cart slash wishlist, your ingress controller will read that slash whatever path you have, then it can automatically forward it to the backend service. Okay, so for this you will have the ingress rules. Okay, so there is this common host name, and then there are paths. So here path is slash, and the other one, I think both are slash only here. Okay, so here this is name based routing, I think this is path based. Okay, so here path is slash, it is forwarding it to one backend. Path is slash Alexa, it is forwarding to a different backend. Okay, similarly in name based routing. Okay, so you'll have names like card.amazon.com. If the client visits in the browser, it forwards to the ingress controller. Now ingress controller will read the whole domain, and then it will send the traffic to card.amazon. Okay, so the backends. Similarly, if he is using wishlist.amazon.in, it might forward the traffic to a different service. Correct? Got it, guys? Okay, so we'll do the same thing here. Okay, so first thing is we will basically need to create certificates. Okay, so here app 1 needs a certificate, app 2 needs a certificate, app 3 needs a certificate. We'll use only one app. Okay, so for this I have a deployment. Okay, so this is connectedcity.com. Okay, so there is this deployment, then there is this internal cluster IP service. Okay, and I am planning to use the ingress controller because I need to offload my um, you know what do you say, guys? We need to offload at the ingress controller, right?
Yes.
Yes, again not
Yes.
responding. Okay, so traffic ingress controller, again I need to, oh, I deleted this, right? Oh, minikube is not working properly. Okay, so let me quickly create it, guys, again. Sorry for this. Let's go with two nodes. Unnecessarily, it's not getting created. Okay, so while it is creating, okay, so let's see how to offload. Okay, so for every application we need a TLS certificate and the key. Okay, so which means, what is the procedure, guys? Let's say for a domain, let's say called mynginx.com. Okay, so needs a TLS certificate. What I'll do, first I'll create a private key
Key and
and a CSR. So the CSR will send to the CA. CA will give you the certificate. So
certificate.
ultimately you should have certificate and private key with you. Since I don't have the CA, okay, you can create your own CA and then basically approve the CSR. But you can create a self-signed certificate, right? Self-signed certificate in the sense a certificate that is signed by its own
Own
private
private
key.
key.
So which means I can generate a certificate and the key with a single command. Okay, so for this what I will do is, okay, I will use this command OpenSSL request for a certificate, and then it will also give you the key. Okay, so let's try to create a self-signed certificate. Okay, so first let's create the certificate and the key. Okay, so it will ask for some CSR information. Of course, you can also use csr.configuration file and then give it as a configuration file. So that also you can do. Okay, so locality, anything. Okay, organization, something. So common name is important here. So as a common name, I'll simply use mynginx.com. Okay, email address I don't require. So it has generated a certificate and a key. So this certificate and the key, if I directly use at the app level, then offloading app occurs uh, uh, at the app level, which means from the user till your application it will be all encrypted. But I will offload just at the TLS only. Okay, so not to burden the application. So from the user to the ingress control, it is all HTTPS. From ingress to all the backends, it is purely HTTP. Okay, so for this what I have to do is I have to provide that certificate and key to the ingress controller, right? Clear, guys?
Yeah, Vicky.
Understood. So for this I will go to this secrets section. So there is something known as TLS secret. Okay, where this secret is of type TLS, which means it will simply create a secret of type TLS. The name of the secret is my TLS secret, and you have to give the certificate and your private key path. That's it. Okay, so I have to create a secret, and then Okay, so you can also create a secret directly from the declarative. Okay, API version secret metadata. Here type is a TLS secret. And what should be the data inside that secret? It is your certificate and it is your key. Okay, so directly do not put the certificate and the key data here. They should be what? Tell me.
Encoded in.
Encoded in base 64. Okay,
Yes.
otherwise you can simply create it like this. Now you have the secret. Okay, if I just show you the normal ingress rules that we use. Okay, so we ideally use this type of ingress rules for the domain based. So here, if the host is flask-hello.com, it is simply sending the data to the Flask Hello service. Okay, similarly, if the DNS is Flask Greet, it will forward. But here, if you see, there is no certificate and key that I mentioned for this domain and also for this domain. Okay, so how do I mention this? Because when I want to offload it at ingress controller, so ingress controller should run as an independent pod. You should not add any external certificates or reconfigure it every time. All the configurations of the ingress controller should come from the ingress. Okay, which means for each of these domains, the certificate and key associated for this domain for TLS should be available within the ingress. So for this, in the ingress, there is this offloading given. Okay, so if you go to the ingress, basically this section. Okay, so there is this TLS part in the ingress. Okay, so what they are saying is, if you have the base 64 certificate and key in the form of a secret, then for all the ingress rules. Okay, so let me just copy and show you. So this is normally an ingress rule where the rule says, if the domain is this, the ingress controller should forward the traffic to this particular backend service on this port. Okay, if we want to enable the encryption, okay, between the client and this particular domain, the ingress controller should offload it, okay, with TLS secrets, okay, for this domain. So what I did here, since I created a TLS secret that has a certificate and key for that domain, that secret is named this. And in the TLS parts, you can see I have this DNS and an associated secret that contains the certificate and key for this domain. Okay, got it? Now within the same ingress controller, let's say you have one more let's say domain based routing. So let's say assume let's say I say this is x.com. Okay, so this is something like y.com. Okay, so they are forwarding it to their respective backend. So x.com, there is a certificate and key. I created a TLS secret. That secret name is, let's say assume, x secret, and that x secret is for the x.com. Again, I have one more y.com. For that also I need, again, simply just you need to copy paste it. So for the y.com, so there is this y secret that has its certificate and key. Got it?
Yeah.
Okay, so now you have offloaded TLS at the ingress controller, which means a client will see the HTTPS. Okay, so let's see how to do that in our real scenario. So yeah, our cluster is ready. Okay, so let me quickly. Okay, so first we need the ingress controller. So we know how to deploy it. So we need to add the repo, update it, and install the traffic ingress controller. The traffic ingress controller is already added as the Helm repository. Okay, otherwise you can add run both these commands, and then this will install the traffic ingress controller. this service is exposed as the uh, load balancer. Okay, so that is fine. Now here there is this deployment connectedcity.com, an associated cluster IP service. Okay, which is the target port is 5000 because my actual container is listening on 5000. Okay, and the incoming port is 80. That's fine. Now if you see the ingress, okay, so this part is well known. Okay, so here what I'm saying, if the domain is mynginx.com, okay, so which one we have used, guys, as the domain name? It is mynginx.com. Okay, so here this is simply a domain based routing. So mynginx.com will route the traffic to the backend connected city service. Now I have a TLS secret. Okay, anyways we will create a TLS secret now. That secret name you have to give here, and that secret is for mynginx.com. Okay, so first I'll show you what will happen without TLS. Okay, so this is without TLS. So let's first deploy or deployment and the associated service and the ingress rule for it. Okay, kubectl get pod service and ingress. Your traffic ingress controller is itself load balancer. Load balancer service type is pending. Okay, so let's wait. Okay, and also the DNS name is mynginx.com. Okay, so the mynginx should point to the ingress controllers load balancer IP, which we already know. Okay, so let's go to the networking. Load balancers. Okay, load balancer here it is already provisioned. Okay, so let me add a new entry. So mynginx.com, that's it. Okay, and then I'll flush the DNS cache. Okay, once it is done I can simply use mynginx.com. Then I will see the, okay, actually the domain name mynginx, but it is not nginx, it is some site. Okay, just don't get confused. See, if I try to use https here, it won't work. Okay, just a second, guys. So is there any other TLS secret already created? It is not created. Okay, connection is insecure, certificate is not valid. Okay, okay, so here if you see this certificate, this traffic ingress controller is having a certificate. It has its own certificate, that's why it is allowing HTTPS. But here this certificate for my nginx, you can see here it is not issued by anyone. Okay, so for this what we will do is we will create a TLS secret for this domain, and then we will offload at the ingress controller. For this just use this command kubectl create secret TLS type. The name of the secret is my TLS secret. Key is domain.key and certificate is domain.crt, because we already created both of them in the earlier steps. Okay, so let's create the TLS secret. Okay, now in the ingress you need to add this TLS secret. Okay, so the TLS is for the host mynginx.com, and mynginx.com certificate and key are available in which secret? My TLS secret. Got it, guys? Understood? Okay, now what I have to do? I have to simply reapply this file. Got it? So it is configured. Now I can simply refresh this page. This time if I see the certificate, okay, so let me just open it in uh, incognito. Okay, and see here. Okay, the reason why it is not verified, because it is self-signed certificate. But you can see the data, right? Who signed it, and it is issued to whom, which means TLS is working, right?
Yeah,
So if you
okay.
get a proper
Yes.
certificate and certificate from the known certificate authority, and if you follow
Mm.
the same method, you will offload it at the ingress controller.